am 303. I hope you enjoy this video. Warning, don't try anything I do without taking proper precautions. Protect your skin, eyes, and lungs. This is part 4 of separating the brass golden chicken looking thing into copper and zinc. So we're starting this video out with about 15.3 grams of undissolved brass. Hey wait, 3, at the end of the last video you had 15.667 grams. Yes, you're right. We tried more mechanical separation with the pulverizing method. We replaced the cardboard box with a plastic box. We had a little bit better results, but we still lost about 1/3 of a gram. While I was explaining all that, the action has already started in the video. So what we're doing here is an exact repeat of what we did in the third video. We are adding a little bit at a time, allowing things to dissolve, and then decanting off the solution that we're producing. Like in the last video, we repeated this 5 times. And now, like we did before, we're separating off the undissolved pieces and the sediment. And we're going to boil down all of our solution and get it as concentrated as we can. I'm a little bit amazed, but not really all that surprised, because I took the undissolved pieces and weighed them out, which means by repeating the exact same process, we dissolve almost the same amount, 6.4 grams. The solution that's not on the super scientific hot plate is everything from the first 3 episodes. So when I started reducing this, we had about 2,000 milliliters or 2 liters or half a gallon or 2 quarts. Okay, so now it's all together in one beaker on the super scientific hot plate. We got it down to less than 400 milliliters or less than a pint. For this next step, I was going to need some more zinc. And I had this little piece. It weighs 11.252 grams, but it wasn't in the shape that I wanted it, so I decided to try to cast it into something that looked kind of like a credit card. So there's the mold that I poured it into. I did film me melting it and pouring it, but somehow that got lost. And this is the result of what happened. It's not perfect, but I wasn't trying to do a perfect cast. I was just trying to make it flat. This looked flat enough, so I think it'll work. I took some dikes and cut out a piece that I wanted to start with. I weighed the piece out to make sure I knew how much more zinc I was adding to the solution. I tied a piece of fishing line to it so that I could hang it in a jar. I started with a little bit of the solution to see how it would work. When I noticed that it was doing what I wanted it to, I added about half of our total solution, so that's about 200 milliliters there in this jar with the zinc. Hey, wait, 3, why are you putting more zinc in there? Why'd you choose zinc to do this? So going back to the reactivity series, copper's up here. Theoretically, if we would have added lead, tin, or nickel, it would have displaced the copper, but left us with a solution of zinc and something else. If we would have added something lower, like iron, aluminum, magnesium, it would have theoretically precipitated out both the copper and the zinc. Okay, so this was kind of hard to see. It was hard to film. But if you look closely, you can see what looks like dendrites growing off of the piece of zinc. And you can see here, there's a pile of material building underneath the piece of zinc. From this angle, you can really see the vigorous reaction. From the side view, you can really tell that there's a growth there. So right around here, the piece breaks in half. So I took the half piece out of the jar. Then we're going to try to carefully decant this off and look at all of the sediment that's in the bottom now. So then we put it on the super scientific hot plate and dried it out. And here's a closer look. You can see there looks like mostly copper, and there are some obvious black flakes in it. The black flakes are probably not copper, and I think I might know what they are, but I'm not sure at this point. So we added the half piece back in to continue the reaction. And now that the solution is a little bit lighter, you can see what looks like obvious copper growth on the bottom. And if you look down at the bottom of the vessel, right now it's kind of hard to tell, but it starts to really look like copper. So since the solution was still very blue and this piece was getting dissolved, I decided to take the rest of the pieces that we had from the credit card type casting, weigh them out, and do the same thing we did with the original piece. I didn't start filming again until they had been in the solution for a while, but you can see there's a lot of pieces falling off and the solution is a lot more clear. It's still blue, but it's a lot more clear than it was. I put this part out on a short. I hope it didn't spoil it for anybody that was waiting on this. But you can really see in the bottom there that that's copper. This is a little while later, and you can tell that the solution is a lot more clear, and it still has a pretty vigorous reaction from all the bubbles coming off of it. here the solution is almost completely clear and the reaction has slowed down considerably. So at this point, I'm going to remove the zinc strips. So this is what we're left with now. It appears that all of the copper is out of the solution and solid on the bottom there. However, there's quite a bit of black flakes in there. I tried to let it go a little bit longer to see if they would continue to dissolve, but the reaction has stopped completely. There's no bubbles coming off of anything now. I think I'll wrap this one up here because you can see the progress that we made, and I'll try to decide what to do for the follow-up to this one. Thank you for watching. I really appreciate y'all. The end.